Welcome to the first of two videos over Class Notes 1-7. We are in Unit 1. This is the 7th page of Unit 1. So for those of you that are printing out your handouts and so forth to keep in your binder, which I hope you are keeping a chemistry binder, a great skill to continue to utilize during distance learning, are those skills that you'll need when distance learning is over, and that's keeping an organized binder. So this would be the 7th page in the Unit 1 section of your binder. Today we're going to be talking about the properties of matter. If you recall, chemistry is a science which studies the properties of matter, the reactions matter undergoes, energy changes that accompany those changes that matter undergoes. We're going to focus on properties of matter right now because the true question that we are looking at in this first unit is, how do you know whether something is actually gold, whether something is copper, whether you're able to turn copper into gold as the alchemist tried to do, or other base metals into gold as the alchemist tried to do? Well, one way to really determine what substance you have is to use the properties that identify that substance. Properties can be categorized several ways. One way we can categorize properties is whether they are extensive properties or whether they are intensive properties. What's the difference between extensive and intensive? Extensive is just a property that depends on how much of the matter is there. In other words, if you extend how much of the matter you have, that property, that particular property you're talking about, will change. Obviously, mass would be extensive. If we were massing coins to try to determine their density and prove whether or not they were gold or silver, we would have to measure the coin's mass as well as the volume. Mass is the amount of matter in an object. Volume is the amount of matter that object takes up. Well, if you add how many coins you have, both the mass and the volume would go up. If you add the number of coins you're massing, the volume of those coins would go up as you're adding coins to it. You extended how much you had, the property changed, it's extensive. The amount of energy something has is also extensive. There are different forms of energy. One form of energy is heat energy. Heat energy refers to how many molecules you have. It depends on how many molecules you have and how fast those molecules are moving. Let's take an example. Let's say that we have a thimble full of hot water and we have a gallon bucket full of hot water. Which one has more heat? Well, if both of those samples of water, if the thimble and the bucket were at the same temperature, maybe they're very hot, close to boiling, maybe they're 90 degrees Celsius, close to boiling point of 100 degrees Celsius, they would have the same temperature if they were both at 90, but they would have different amounts of heat. How do you know that? Well, if you dropped a big ice cube into the thimble, its temperature would drop significantly. If you dropped an ice cube into the bucket of water, its temperature would barely change at all. Why? The bucket has more molecules. It would take more ice to get them to cool because it has more heat. Extensive, it depends on how much is there. Intensive properties, that's a category of properties that does not depend on how much is there. It's a property inside the object, intensive, inside. For instance, the color of something really doesn't matter how much is there. If you are wearing a blue Firebird or navy blue Firebird shirt and you tear the sleeve off, you changed how much is there, but the color didn't change. The melting point of something doesn't matter how much is there. Ice cubes that we were talking about in the previous example. Ice melts at 0 Celsius or 32 Fahrenheit. It doesn't matter whether you have an ice cube or a glacier. They would still melt at the same temperature. The boiling point of water doesn't matter how much is there. The thimbleful of water would have to be raised to 100 degrees Celsius to get it to boil. The gallon would also have to be raised to 100 degrees Celsius in order to get it to boil. However, they have the same boiling point because boiling point is intensive. But it would take more heat energy to get the gallon of water up to 100 because you have more water in the gallon bucket. Again, heat is an energy. Boiling point is a temperature. Temperature is intensive, heat is extensive. The density of something is affected by two extensive properties. The density of a substance matters both on its mass and its volume. If you recall, density is the amount of matter crammed into a space. It's mass divided by volume. But the density itself is intensive. The density of a substance doesn't depend on how much is there. So an ice cube has the same density as a glacier of ice. A gallon of water has the same density as a drop of liquid water. That is a good thing. Why does a drop of water have the same density as a gallon of water? Well, the drop of water has a much smaller mass and a much smaller volume. Small divided by small. The gallon of water has a bigger mass and a bigger volume. Big divided by big could be small. Small divided by small can be small. Or whatever. Density of a substance doesn't matter how much is there. If a drop of water was less dense than a gallon of water, you would have to be very careful about the size of your water bottle, because density is the amount of matter crammed into a space. If the density went up, the bigger your water bottle was, it might cause you to choke on the water. Water's water. Intensive is a property inside it. Extensive matters how much is there. It's a property inside it. Doesn't matter. Intensive doesn't matter how much is there. That's two ways of looking at properties, extensive and intensive. There's other ways of looking at properties. We have physical properties and we have chemical properties. These are two very different ways of looking at a substance. Physical properties are properties that can be observed without changing the substance. Chemical properties relate to the ability of the substance to undergo chemical changes and be transferred into different substances. In other words, chemical properties look at how a particular substance behaves chemically, how it reacts with other substances. Physical properties, you don't need other substances. You're not looking at how it reacts. You're just looking at things that particular substance, things that can be observed without changing what is there. Chemical properties, in order to observe those, you could potentially change that substance into another substance. So physical properties describe the substance. It does not describe how the substance behaves. Examples of physical properties include both qualitative are just qualities of the substance, and quantitative physical properties. Quantitative are things you would measure regarding the substance. So what are some qualities you could observe without changing what is there? State of matter, whether it's a solid, liquid, or gas. The color of something you can observe without making a measurement. The odor of something you could make without making a measurement. You're just looking how it smells. Its texture, you don't need to make a measurement. You can just feel, is the surface rough? Is it smooth? The shape of the crystalline shape. You don't need to measure something. You're looking at its shape. Malleability is how well it can be pounded thin and bent into shapes. Malleability, how well something can be pounded and bent. You don't have to make measurements on that. You're just making a comparison. Ductility is how well it can be rolled and stretched into wire or tubes. Metals are malleable and ductile. Non-metals are not. Non-metals are not easily pounded thin and bent into shapes. Non-metals are not good at being drawn into wire or tubes, but those are qualities of a substance. How hard a substance is, whether the substance is brittle or not. Non-metals tend to be brittle. Brittle means they're not bendable. If you try to bend them, they shatter or break. Quantitative refers to measuring a quantity. The melting point, the substance, the temperature at which a substance melts, you would have to measure that using a thermometer. The temperature at which a substance goes from a liquid to a gas is its boiling point. You would need a thermometer. The density is an intensive property, but you have to make two measurements. You need to measure the substance's mass and divide it by the substance's volume. Solubility is how well a substance dissolves. How many grams of a substance or kilograms of a substance you can dissolve in a particular solvent. That you would measure. How well it conducts electricity. You would measure it. How well it conducts heat, which is thermal conductivity. You would measure it. So physical properties, if you notice, we did not mention reacting it chemically with something. We're just describing how its properties are without reacting it. Physical changes are changes that occur in a substance without changing what the substance is. A physical change is when you're looking at something that's changed physically, what you started with is the same thing as what you ended with. Physical changes, often remembered by the letter S. Solubility is a physical change. When you dissolve something in a solvent or another liquid, when you dissolve something in a liquid, which is very often a solvent, the substance is still in there. It's still in the liquid. You can get it back out by evaporating off the liquid. So if you put salt in water, you now would know salt is soluble in water. But the salt is still in the water. If you evaporate the water away, you could get the salt. A change in something's shape, size, or state of matter are all physical changes. If you bend it into another shape, it's the same thing. It's just in a different shape. If you smash it into a smaller size, it's the same thing. If you take water and it's in ice form and you melt it, it's now a liquid. It's liquid water. If you evaporate it, it's now a gas. It's now water vapor. What are chemical properties then? Chemical properties relate to how well a substance reacts with other substances, how well it can be transformed into other substances through chemical reactions. Chemical properties include things such as, does it rust? Does it burn? In other words, combust or flammable. Does it react with particular things? Those are all chemical properties. What are evidences that a chemical property is being impacted as an object is reacting with something else to form a new product or compound? How do you know, for instance, that chemical changes are occurring? Very often, chemical changes are accompanied with flames, burning. You might see smoke coming off. You might see fizzing and bubbling as a gas is formed. You might see a precipitate form, which is where a solid is formed that is no longer soluble. You might see a flash or color change. You might see a flash of light. That's all evidence that a chemical reaction is occurring. In a chemical change, it is a process where one or more substances are converted into different substances that have an entirely new chemical identity. In our next video, we're going to talk about what chemical reactions are. That is the process of producing new substances through chemical changes. So in our next video, we will pick right back up with this part of our 1-7 notes. Thank you for watching.